Hello and welcome to our lesson of power of a power property. First, let's talk about the definition. If you have power of a power, it means that you raise your base, that big number, and the exponent. Both of them together, you raise them up to another exponent. We're going to take a look at what that looks like. So if we say the quantity 5 squared, that's right there, raised to the 4th power. So we're taking the whole 5 squared and we're bringing it up 4 more times. But I said the quantity, and when we say quantity in algebra, we mean that the entire expression before the second set of exponents. In other words, quantity is indicated by parentheses around the 5 squared. So you're looking at the quantity of, tells you right there, you've got a parenthesis. And I said the quantity of 5 squared. That's the whole thing that you're taking and raising it to the 4th power. So let's go ahead and do that. If you have the entire quantity of 5 squared and you're raising it to the 4th power, that means that you're going to take 5 squared first, which is 25, and you're going to raise it to the 4th power, which means you've got 25 times 25. It's going to be 4 times in a row. And one more time. So if you have all that, it's going to be a massively large number. It's going to end up being 390,625. That's when we took 5 squared, the quantity. That means the entire amount, 25 is 5 squared, and raised it 4 times in a row. And we got this huge number. Let's take a look at some more. Remember that you have to follow PEMDAS rules. Parentheses first, so you have to deal with everything inside the parentheses. And then comes exponents, which we're focusing on right here. So first thing we have to do is parentheses, 4 squared. That's our very first thing. And if we take 4 squared, it's 4 times 4 is 16. Now, PEMDAS says we deal with all our parentheses, which we did. Now we have to look at any exponents, and we've got one right there. So what it's telling us is to take that 16 and multiply it by itself 3 times in a row. We did everything inside the parentheses first, and that was the 4 times 4, and that's where we got our 16. And then we did the outside exponents, which is when we took our 16 and raised it to the 3rd power. Okay, let's take a look at some more examples. Here we have something that should look kind of familiar. We've got 4 squared, and it's the whole quantity. So 4 times 4 is 16, and we're raising it to the 3rd power. So that means we're taking it 16 times 16 times 16. And if you do that, you're going to end up with another big number, and that's going to be a total of 4,096. So this right here is your final answer. When you take the entire quantity of 4 squared and you raise it to the 3rd power. So let's try it again. Now you've got a negative 5 raised to the 4th power. So you're talking about negative 5 times negative 5, and you're going to do it 4 times in a row. Now if you have a negative times a negative, that makes it positive. And we have another negative times another negative, that makes it positive. And a positive times a positive is still going to be a positive. Okay, so if you take 5 4 times in a row, you're going to end up with a really big number, and that's going to be 625. But we're not done yet, because that all was just this inside portion. Now, PEMDAS says you deal with that outside exponent, so you're going to take 625 and square it. Huge number. It's going to be 390,625, because you're taking 625 times 625. All right. What if you have a fraction for a coefficient or for a whole number? It works the same exact way. PEMDAS says deal with everything that's inside this set of parentheses first. So you're going to take 1/2 and you're going to multiply it by itself 4 times in a row. Remember, when you multiply fractions, you're just multiplying straight across. So multiply all your numerators first, and 1 times itself is always going to be 1. And then you're going to multiply your denominators. 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So we just dealt with that parentheses portion. We got that done. Now they're saying take that to the 5th power. It's a massively large number. You're going to end up with number 1 5 times in a row. It's still going to be 1. However, if you multiply 16 5 times in a row, you're going to end up with 1,000,000 48,576. Huge number for a denominator. However, if you think about it, this is a fraction, and you're taking one little piece out of a million. It's so tiny. All right, look at the next one. Now we're going to take 2 to the third, always the parentheses first, so let's deal with that. The negative, we'll just rewrite it and talk about it in a second. So you're going to take 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. So you're going to have that negative still there, 8, and then you're going to raise it to the 4th power. Now, PEMDAS says that you have to do parentheses, exponents, and then multiplication. That negative on the outside is all about multiplication, so that's the last thing we're going to deal with. Right now we're going to take 8 to the 4th, which means you're multiplying 8 4 times in a row. So let's go up here to right. You've got 8 times 8 times 8 times 8. And 8 to the 4th is going to equal 4,096. But you still have that negative sitting outside. So if you multiply a negative times a positive, it just flips the sign. So your final answer is going to be negative 4,096. Right there. Okay, so for a quick review, when there's a set of parentheses within the expression or equation, you have to do what's in the parentheses first. That's what PEMDAS says. Once you've raised the base to the power inside of the parentheses, that was our first thing we did, then you deal with that new number you created and raise it to the power that's outside the parentheses. Remember, it's parentheses, then exponents. Remember, any negatives outside the parentheses mean that you just flip the sign of your final answer. Because remember, we had the 4,096 as our answer before the negative. It was a positive number, and all it told us to do was flip the sign, so that's what we did. And that's why that works. And that's our lesson on powers of powers property.